Bill Owen, how are you today?
I'm doing good, thanks.
Excellent. Thank you very much for coming on to what is going to be the first of our series of rotating discussions for SurveyHub.ai.
Oh, great.
Uh,
First victim or first success story? We'll see.
yes, to be determined, I'm sure. Kind of opening up the discussion. We've known each other for probably almost 10 years now. That's pretty scary. Uh, what's your title now at Caltrans?
hmm well, I'm the chief of the Geophysics and Geology Branch. So, what we do is we provide geophysical surveys on a more like a client consultant basis, where we act as an internal consultant to the Department of Transportation. So when we have projects that are in design, or if we have some emergency work that requires some non-destructive testing or some geophysical survey, we get a phone call. We go out and we respond. We collect data. We analyze the data. We come up with interpretations and we write reports and we help support our geotechnical designers and our roadway maintenance people and our bridge inspectors, the various groups within the department that require those kinds of services. And so one of the more interesting things that we've started doing over the past few years is we've been getting more into the utility locating business, which is kind of the all of our maintenance stations are currently into there's at one stage or another they are essentially rebuilding and reconstructing a lot of our aging buildings in our transportation maintenance stations, and none of those have very good records on where their utilities are. So they've asked us if we can go out and help them, and so we don't advertise ourselves as a SU provider, but we at least can go out and do a partial utility locating service for them to give them more information than they had to start with. And so they seem to be pretty appreciative of that work, and that's something that's been keeping us busy over the past few months. So that's kind of in a nutshell what we do. We work on anything from the utility issues all the way to doing pavement inspections and working with our geologists and geotechnical staff on the deep foundation studies. So we might be called upon to do some borehole geophysical logging. We might do some seismic work. And so it kind of runs the gamut between very shallow to shallow to middling deep work for some of our stuff. So we're pretty broad based. Currently have a staff of 8 people that do this work, and we respond throughout the state. So it's been keeping us very busy. Seen a huge uptick in work within like the past 6 months or so, which is keeping us extremely busy at the moment. But hopefully
What
we
do
can
you
get
think
down
that's
to.
for? From
It might be primarily because there's kind of a recognition that some of the geophysical services that we provide can augment what we normally do for drilling and sampling. So typically, whenever we go out and we have a let's say a geotechnical project, we're going to do some roadway excavation. We're going to realign a roadway, or we're going to build a new bridge. We're going to do something that's going to require turning dirt somewhere. So we will contract out for either contract logging, or we have our own internal logging services. And with those resources getting stretched thin, and some of the environmental restrictions that we're currently seeing for those kind of services, there's been kind of a recognition that the geophysical component can augment what's being done at the drill hole, and so we can either expand information beyond the drill hole, or we can correlate between borings to try to expand information where they normally would not be able to get that information.
and most of the equipment, if you want to say toys that you play with, are really on the NDT space as opposed to going in and digging holes and that kind of physical damage types of surveys. Correct?
Yeah, correct. So we like to kind of distinguish between NDT and geophysics. And it's pretty simple. If we're doing some kind of non-destructive test on naturally occurring earth materials, we call that geophysics. If we're doing it to a man-made structure, we call it non-destructive testing. So we might be running a radar survey to find sinkholes in naturally occurring ground, and that'd be a geophysical survey. We do the same thing over pavement. That's NDT. So it's kind of a quick and dirty way of kind of discriminating between the two. And so, but
That
we
makes
kind of
sense.
do them both because the most of the tools that we use have some dual use applications. We can do it on man-made structures. We can do it also on naturally occurring ground. So.
Now, when you started coming up, first off, are you a native Californian?
No, I kind of grew up in the military, so I kind of bounced all over the world, and so California was the place I ended up.
Not a bad place to end up, certainly. A lot of worse. Alaska comes to mind, at
Oh,
least
don't
if you
knock
don't
the
like the
Alaskans.
snow.
It's a beautiful state. Jeez.
I've got a friend of mine in California that actually moved there because he did a full study that was the most days of beneficial weather anywhere in the entire world.
Hmm.
So, and it's your backyard right there. Where did you go to school? Were you always kind of interested in science as you were growing up?
Yeah, I was always kind of interested in sciences, and I was kind of odd in that I kind of learned about geophysics fairly young and thought that this sounded like something that would be really interesting to work with. So growing up, middle school, high school, started looking at, was interested in oceanography, looking at astronomy, astrophysics, all of these little things that most other kids weren't terribly interested in. I kind of found fascinating. So I kind of bounced around between all of that, and when the time came to try to pick a major, I was looking around and seeing what was out there and seeing what would be interesting to me and also give me gainful employment. I thought, well, geophysics kind of sounds interesting. Maybe I'll give that a shot.
That's
So
cool.
of course, at that time, if you were going to study geophysics, the assumption was that you would be working in the oil and gas industry. You'd be doing some petroleum exploration, natural gas exploration. You'd be working primarily with gravity, magnetic, seismic reflection, some of the stuff that we consider now as the classical geophysical methods. And it really wasn't until I went into graduate school, and that was either fortunately or unfortunately, I happened to be graduating from school at a time when the bottom fell out of the oil market. So I was kind of looking around with a bachelor's degree in geophysics, wondering what the heck I was going to do with myself. And I had one of my undergraduate professors pulled me aside and said, "I've got this grant money to go out and do this environmental project on this Superfund site. Do you think you might be interested in it?" And I kind of looked around and said, "Well, I have nothing better going on, so I guess I can go back to grad school and kind of hang out and see what's going on there." So that kind of started my career, kind of going from thinking about deep basin studies and looking at the Earth's crust to saying, what's happening in the quaternary sediments that we're dealing with, the stuff that we live on every day, and so that kind of started my path down the road. And as my wife would like to point out, I kind of became shallower and shallower as the years went on and started doing things like borehole geophysical logging, seismic refraction, looking down several hundred feet or 1,000 feet down to looking down to what's going on in the upper foot of a pavement section. So that's kind of like where I've kind of ended up over time. And it was always just more of a matter of these were problems that interested me, and I thought, well, how can we potentially solve this problem? And so, we kind of, my office kind of went from running geophysical surveys to provide foundation studies for roadway construction and bridge construction, to assisting our maintenance people with doing pavement work because they had problems with their pavement. And they said, well, how can we solve this problem? We looked around. I said, well, there's this thing called ground penetrating radar that can do a really good job with really shallow features, and so maybe we should think about doing that. As it turns out, we discovered that something that we originally thought we were going to use for geotechnical applications actually became a maintenance type and roadway pavement construction tool for us. And we kind of were doing that. Fortunately, timing was right. There were a whole bunch of other people that were doing the same thing, statewide, nationwide, worldwide, who were kind of coming to those same conclusions. And so we all kind of progressed down this road. to kind of where we are today, where we have where there's a recognition that GPR is a mature technology that has great applications for non-destructive testing for pavements and bridge decks, structures in general. So that's kind of the gist of where I ended up. So we still do a lot of geophysical surveys in my group, but we're kind of bifurcated at the moment. So we have groups of people that go out and do the seismic refraction tomography investigations for our geotechnical side, and then we have the people that are going out and doing the magnetics, electromagnetics, ground penetrating radar stuff in support of our NDT stuff. So that's kind of in a nutshell what we do here at Caltrans.
So coming out of college with more like a broader based geophysics type of background and with a heavy dose of geology, it sounds like, do you think that grounding in a wider sense gave you a foot up to see the evolving technology coming out of, say, the 90s into the 2000s and the way that things had kind of developed and the way that you took some of the new technologies and started applying it to other problems that you didn't really see at first?
Yeah, I think in terms of that, it kind of gave us some advantages, at least internally within our group, because I started with Department of Transportation in 1994, and so been doing this now for 30 years with this organization, and kind of having the background in geology, we could see where these tools were coming on board, and looking at them and saying, this might be something that we can actually apply to some real life problems that we have. And then as it goes on, kind of making mistakes, learning lessons, figuring out what the tools are good for that we originally thought might be good for one particular application turns out to be very good at other applications. So it's kind of been that kind of learning experience over the years, and having the background, broad-based background in geology and geophysics makes probably helped out a lot in the long term. I know I've had conversations with other colleagues in the industry. Phil Searles is a friend of mine who comes to mind, and so one of the things that he's always emphasized as well is that in order to be a good geophysicist, you also need to be a good geologist. You need to understand what these signals are that you're measuring, what they mean in terms of what's going on underground. And so it became a fairly easy shift to take that same kind of knowledge and say, here's what we think is going on underground based on what we're observing from these, ephemeral signals that we're measuring, to what's going on in a pavement or what's going on in a structure, because the physics is the same. It responds to certain phenomenon, and knowing how those phenomenon are or what those phenomenon are kind of makes all the difference in trying to have from a successful survey to an unsuccessful one.
And when you were making that shift into things like, human engineered stuff, transportation systems, bridges, roads, that kind of stuff, did it help or hurt that you knew I'm sure it helped that you understood the physics behind the materials, but not knowing the civil engineering or not having come up as a civil engineer, specifically a road builder or a bridge builder, to learn those structures and understand what you were seeing in, for instance, like a radargram. Was that a difficult transition, or was it basically just the material is a material?
Yeah. Difficult versus challenge. It was a challenge because it required us to not just me, but the people that work for me and work with me, having to just take a step back and say, okay, we're seeing some kind of signal. How does that correspond to what's in this particular structure? And so it required us to kind of have some, develop some engineering understandings. How are structures built? What goes into them? How does rebar help a structure? How does the sub-base and base layers in pavement? How does that affect pavement construction? One of the biggest bugaboos that we ever had was how do we distinguish between Portland cement concrete pavement versus cement treated base underneath it? Everybody, I think, who hears that just knows they're rolling their eyes, going, "Yeah, that's been." Nobody's ever figured out the answer to that one. But there's, those kind of challenges. It required us to ask those fundamental questions. So we had to work pretty closely with our engineers, people that actually build the stuff, to give us some ideas. And fortunately, compared to geology, we do have, at least we have as-builts that we can look at for structures that tell us here's how the thing should have been built, so we can look at it and then verify, was it built according to the as-built, or was there some kind of deviation from the plan based on what we see in the information? So it's been kind of a challenge, but it's also been a lot of fun, because everything is a puzzle in some way or another, and it's solving those kind of puzzles that those kind of challenges that kind of get me up out of the bed in the morning and make me want to come into work and do something that I feel is productive.
Well, it sounds like you've had a good structure that allowed you to experiment and build the capacity of your group as you started moving forward, where you were allowed to pick up new toys and experiment with them and try them in different situations. I mean, it would be harder if you were more tightly bound and expected to probably say this tool does this and that's it.
Yeah, yeah. I mean, it's really helped to work for an organization that really isn't risk averse. There's an understanding that we take risks in everything that we do, and how do we? So the question then becomes, how do we control those risks, or how do we optimize those risks such that we can end up with a product that is both functional, safe, and has a lifespan that we would expect to have for it. And so we've I've been fortunate in that I've worked with some good people, and the people that have been above me have understood the kind of the challenges that we do, or that we face, and also a little understanding of the rewards that can come from this. And so by kind of rolling the dice and taking these risks, with something that they may not necessarily have a great background in, but by me being able to discuss with them and show them how we can apply these things in our daily job, and how this information can assist with the problem at hand, either geotechnical, maintenance, construction, or otherwise, has been a big plus. Having people that understand that and say, they've been willing to take that kind of risk and fund the program and allow us to go out and have these successes. And there have been mistakes along the way too, and that's all part of the learning process. Everybody, I'm sure, has those projects where they looked at and they said, yeah, that one didn't work as well as we would have hoped. But you take those mistakes and you move forward from that, and you learn from those, and that's how you make progress in anything. And we have lots of examples, in the modern world of people who are doing that to this day. And so we're kind of different. I mean, we're not sending rocket ships to Mars or anything, but it's kind of taking things that might have been tools that might have been developed for one particular application and adapting them for other uses, and having those successes and showing people how it can give them information and also give them cost-effective information. Showing them here's how you can actually save some money by improving your knowledge base on a particular problem, and trying to avoid situations where you have problems in construction because you've identified the problem ahead of time. And having these geophysical and NDT tools has helped out in many respects, in those applications.
Do you have an example, like off the top of your head, about where maybe repurposing one tool worked super well in being able to apply to another project or another problem, and it became kind of a standard way of doing business after that?
Yeah, I think we've already touched on that in many respects. At least and the one tool that you and I are both well familiar with, ground penetrating radar, is probably one of the best examples of of a tool that was developed originally for one thing that was what turns out to be much better at other things. So when we first started using ground penetrating radar, we were using it for geological problems. So we were trying to say, can we identify fractures in rock masses? Can we find geologic contacts in the ground with radar? How can this help us to address geotechnical problems? And what we quickly discovered in California is that unlike some other states, California has a lot of clay and overburden. So gravity, or not gravity, but ground penetrating radar as compared to gravity, for example, which is kind of transparent to everything, but ground penetrating radar really is severely impacted by brackish water, saline water, clay content in soil, and so it really became a situation where, the joke in California is that gravity, or I keep saying gravity, I apologize, but ground penetrating radar, it starts with a G, that's why. Ground penetrating radar works great in places where nobody lives. Where you have out in the desert, out in Owens Valley area, places where we have things like the Bishop Tuff, which is one particular problem in one very specific location. Ground penetrating radar works amazingly well. But when you get into the Central Valley in California, not so much. It becomes very hit and miss. But then we quickly discovered that it might not work great for geology everywhere in California, but it is very useful for pavement. In particular, it's very useful for asphalt pavement. So we have lots and lots of asphalt pavement in California. We have lots and lots of problems with asphalt pavement. And so it became kind of a natural transition to say, hey, we've got this tool. We originally wanted to use it for this, but you have this problem over here. How about you give us an opportunity to go out and use it? And so when we had some engineers that would have some particular problem, they'd see an issue, and we'd kind of raise our hands and say, "Can we go out and take a look at this?" And we'd go out and look at it, and sure enough, we were able to show them that there's some very useful information that we can get out of this using this one particular tool. And so you can kind of see at the same time, from your side as well, you can see that there's this great market for it, if you will. And so there is this time, as the technology has matured and people have kind of recognized the utility of ground penetrating radar for pavements, we see more and more of the technology being geared towards that specific function. And so this is kind of where we kind of ended up at to this day, with having the contour system that allows us to collect a couple of 100 miles of radar data in a few hours. So it's been just a great expansion into finding practical solutions for our engineers for problems related to their pavements using this particular tool.
And how hard was it when you're looking at, you've got GPR, you've got IR, you've got seismic tools, you've got different types of GPR, and you've got an 8-man staff. How hard is it to develop the flexibility and the capability inside of that staff to be able to kind of answer these different types of technologies and then be able to spit forth different types of deliverables to a lot of different audiences?
Yeah, that's tough, and it goes back to the one of my original statements early on in this discussion is that we've kind of become a bifurcated group where we have people who are specialists in certain applications, and so we have people that are specialists in the seismic side who are doing refraction tomography, multi-channel analysis of surface waves, those kind of applications. I have some people that are doing borehole geophysical logging. They have specific tools and specific techniques and processes that they have to use for that. And then we have the NDT side, where we have the ground penetrating radar, the electromagnetics, the magnetometer work, and the pipe and cable locators, those types of tools. And so we have people who are specialized or who have a great deal of experience and knowledge in one side, and they can they can cross train and provide assistance on the other side of the shop. But for the most part, we have people that are kind of, trained up on specific techniques so that they can provide, that kind of specialized service, and they can assist on other sides. But it's been a challenge trying to do that kind of cross training and keep people cross trained, because they're also it's also by their individual desires and their individual level of knowledge as well. We have people who are extremely interested in running, for example, the ground penetrating radar side, and those people, they might not be terribly interested in what's going on the geotechnical side. Conversely, we've got people who are doing the seismic side, who are doing all of that work for our geotechnical program, and they can cross train. They can work back and forth. We've got people who do the seismic stuff who can also run the EM and the MAG systems, and they can provide support for our utility surveys. So they can provide some support for our unknown foundations detections that we have to work on periodically. But that's not their primary bread and butter. But so it's always kind of a challenge trying to make sure that we're constantly meeting our needs, both the needs of our people internally, but also making sure that our clients on the geotechnical side and on the maintenance side are getting the services that they need, and getting them in a fashion that they're satisfied with, and that we're doing things properly and doing things correctly for them. So it's constantly training people and constantly getting people out in the field and getting them exposed to these different tools and techniques, and making sure that people at least are staying cross-trained such that they can stay competent in different sides of the shop.
And when you were building them, did you try and say, I need a guy who does X and a guy who does Y, and then start mushing them together? Or did you look for maybe some broader-based people and then fit them into, with internal training to where you needed them?
It's been both approaches have worked pretty well. So sometimes we've started out looking for somebody who can serve a specific function. We have a specific need for certain type of work, and so we would look for somebody that has a background in that can step in and provide that role. But then when we get to that point where as we've essentially developed those different markets, if you will, we also want to bring people in who might have just a broader based education. We also look for people who don't have a lot of experience. We want people who are entry level geophysicists who can come in and learn these tools. We also look for people that have a good educational background, and they may not necessarily have worked with all of these tools, but we can train them up and get them into them and show them how they can work, and then they can pick them up and run with them. I think the borehole geophysical logging is a great example. There really isn't any schools that teach that on a routine basis. Most people will get, if you're going into a geophysics program at a school, depending upon where that school is, you might have a broad brushed approach to some things. For example, you work in, if you go to school in Texas, you might learn about seismic reflection. If you're going to school in California, you might learn about seismology, but you're not necessarily doing the specific tools and processes that are out in the industry. It primarily because there's only so many hours in a day that you have, for students to teach them the basics, and also because their curriculum budgets may not allow them to have those kind of tools. So we kind of anticipate that people will come on board not necessarily having expert knowledge on everything that we do, but we look for people that have the interest and have the aptitude to learn these things, and it's to grab them, bring them on board, train them, and let them be successful here.
Is there a harder learning curve now to pick up the intricacies of some of the new technologies than there used to be as the technologies are advancing?
I don't really think so. I think in terms of what's been happening with the technologies is that the technologies have certainly become more user friendly. So it's become it's become, although it's also made it easier to get very deeper into the woods while you're making mistakes. It's also allowed people, if you're knowledgeable about the particular tools that you're working with, it makes it a lot easier for you to do your job. So you can collect more data, you can collect better data, so in terms of that, no, I think it's the tools that are out there now with the graphics user interfaces. The things are less black box than they used to be. And so it gives people, our people, a much easier time setting up an array or a profile and collecting data and making sure that what they've collected is actually useful for them when they get back to the office to do the data processing and reduction.
Is it? Have you found that it's easier to teach somebody an additional sensor technology if they're already up to speed on one of them? Essentially, is that adaptation curve not that bad?
Yeah, usually if they have a good background in certain techniques, for example, if somebody has come in with some knowledge of resistivity techniques or electromagnetics, it's pretty easy to get them to understand ground penetrating radar. Somebody who might have some background in seismic reflection, for example, extremely easy to transition to ground penetrating radar because the data that they look at, the cross sections that they look at, look very similar to what they'd been doing previously. So it's a fairly easy transition to get them to step in from one role to another. There's always that learning curve. I mean, there are intricacies. I mean, the theories are a little different. The way soils respond to electromagnetic versus acoustic in energy are a little different, but they still are things that if you have a background in one, you can readily learn the other.
So, and if I'm looking at your group essentially as an internal service provider for the greater Caltrans, number one, have you seen, and it sounds like just even recently you've had these jumps in internal demand, a greater acceptance of these technologies as being a useful part of their pre-design maintenance planning, budgetary, planning, all those kinds of things. And I'm kind of lumping all these technologies and NDT stuff together.
Oh, sure.
And do you see that as a continuation, especially with, like, from what I've seen, the newer generations are much more of engineers are much more accepting of technology than perhaps someone who is getting ready to retire now, and because they did something for 30 years the way that it was taught for them, for the guy who did it the same way for 30 years prior to that.
Yeah, certainly. I think a lot of people that are just coming into the industry now, they've been exposed to this. They've seen the success stories on it, so they have an understanding of how these tools can be applied. They may not have a thorough knowledge of it, but they've at least seen an article somewhere, or they've ran across something on the internet where they've seen somebody has applied an NDT tool or a geophysical tool to a specific problem, and they might be looking at it, from their job, a particular problem, and and the bell goes off. They've seen it. They say, I understand. There was this. This guy somewhere did this work, and and it worked out well. Let's see if we can bring this tool on board and be successful with it on our particular project.
And as a service provider, what are the kind of the bigger problems that you're seeing or frustrations with the way the technology is going, or with, let's actually leave it open-ended, right, to anything. What are your biggest frustrations as a service provider?
Mm-hmm. Probably the biggest one is guiding expectations. There's we although we have people that they've been exposed to these kind of tools, and they at least have an idea that these tools can be applied to their project. Without a deep understanding of what these tools can provide and can't provide, it's a lot of times we kind of have to walk a client through a particular project and try to answer their questions, and sometimes we have to tell the client no. It's like, we're sorry, but what the particular situation that you have, we can't provide anything of use to you here, and we don't want to waste your time, we don't want to waste your money. So there's some you might have an idea that these geophysical tools, these NDT tools, can work out here, but we might tell them you're going to be better off just drilling this project and going back to some of the old tools and just getting some good hard data in your hands and taking this stuff to the lab, and that's going to help you out better than anything we can offer. So again, it's kind of guiding expectations for clients, letting them understand what it can do and what it can't do, and taking it from there.
Are you seeing more of a formal acceptance of getting surveys done on either, like, for your customer base internally, that they are now putting a survey as part of their regularly scheduled checklist? Is that happening more than not now?
Yeah, that's actually become a formal process now, where we're considered as part of the design investigation process. So there's always a consideration for our projects, particularly on the geotechnical side. We have our own internal guidance documents now that basically advise our project geologists and our project engineers to consider geophysical applications for their projects. And so it's become a more formal recognition that those tools are available, and at least when you're first starting out the project, at least ask the question, can this be used on this project? And so I think that's part of that's part of the reason why it's led to an increased demand for the service.
And I know you and I have, in past conversations, joked about some of these things, but how good or bad or improving are some of the, let's say, what you're really calling is the internal guidance documents, but like the regulatory areas in different areas, like in between SU or pavements and this, what's your read of where they're going and where they are now?
Mm-hmm. Can you repeat the question? We lost connection there very briefly.
I saw you fuzz out for a second. Yeah. So basically, in talking about the internal guidance documents that kind of are in different areas. So obviously, one for pavement evaluation, one for SU, one for whatever. What's your read of the status of those things and where they're going as an evolving set of rules and documents? Really, obviously, the U.S. the best, but I guess as a general open-ended question also.
Yeah, maybe even not for the U.S., but for California in general. We're seeing more formalization of the evaluation of applicability of these processes. So they're included as part of the project development process. So they're always asking, where can these tools be brought on board? How do we formalize the process of including them? And where in the project phase do we bring them in so that they can provide the most bang for the buck on the projects? Where can they have the most applicability? Where can they provide the best results? The challenges are always going to be training up new staff and getting people to understand that how these tools work and how they're available. And so there's this constant need for training new staff on board as they come on board and letting them know that these tools are out there. And sometimes we actually get them involved, and we get new staff involved in doing the actual field work, so they get a better understanding and they get a little informal education on the field applications. From perspectives of NDT versus geophysics versus inspection services. I think if we look at the three main types of services that we provide, we look at pavements, we look at geotechnical, we look at utilities. I think pavement and geotechnical are much further along in terms of acceptance and understanding of how these tools can work for them. We have much more involvement with our own internal offices, with running pavement inspections and giving people the kind of data that they need for pavement designs, whether it be for example, a full depth reclamation or a partial depth reclamation of pavements, giving them the information that they need to plan and scope out their projects. That's been a real big help, and there's a lot more understanding on that side. On the geotechnical side, obviously, because we've been doing it much longer on the geotechnical side, there is a much better understanding among our geotechnical staff as to what these tools can provide for them. On the utility side, that's been a challenge, and it continues to be a challenge. And a lot of it is the challenges of getting, and it's not just state of California, but I think it's any of the other DOTs or the other states that are involved in this. Getting them involved and getting them to accept the current processes and standards that have been promulgated through ASCE, either ASCE 38 or 3802 or ASCE 38-22. So I think everybody who's looked at the two documents understands that 3822 was a monumental jump in the reporting processes and the reporting standards for utility locating and subsurface utility engineering. And in terms of us internally within California, I think we're at the process where we're just beginning to bring 3802 on board. So we're kind of 20 years behind the curve in developing that. Developing utility engineering as a real formalized process. We are at the point where we've recognized that utility locating is a real challenge and is a valuable process in terms of our project design, because what we have a great understanding that utility clashes in construction are one of the major causes of cost overruns in all of our projects, and that this is something that we have to deal with. But it's been a kind of a long slog getting getting adoption of a formal SUE process on board, and getting the people on board to buy into it. And we that's not to say that we're not doing it. We have some very good people who are currently working on the process. It's just a big hill to climb. There's a big learning curve attached to that, and so we're in many respects, I think we're kind of at the beginning rather than closer to the end of developing some kind of mature SUE process within this Department of Transportation.
Do you think that project or that process is accelerating?
I think it's moving along. It's happening in kind of fits and starts, but we do have some good people who are working on it. But I like to say that we're not alone in terms of states that are doing this. There are lots of states that are having this same problem. Just trying to adopt these processes is proving to be a big challenge nationwide, and even some of the states that originally were kind of the pioneers in this have had issues with keeping it going with transitions of personnel and loss of institutional knowledge as people have matured and retired, and people who were originally doing these things have moved on, and the people in the executive management have not done the proper things that they needed to do to maintain those, to maintain that institutional knowledge. But I think people are kind of catching on and understanding that it's something that needs to be done in terms of a long-term approach. And so we're certainly, I'd say, compared to 10 years ago, we're better off than we were, but we still have a long ways to go.
You bring up an interesting question there, which is, as I've talked to different people inside of the survey world, there seems to be, we are on kind of a little bit of a hill where there's a big mass of people that are retiring, and they're taking a lot of institutional knowledge with them. And there's not nearly as many people coming up through the ranks anymore to be able to effectively replace those guys. Are you seeing kind of the same thing in your experience?
I think it's been a challenge, but it's not just on the surveys and investigation side. It's on the engineering side in general. I know for many years with the Department of Transportation here in California has taken a look at the numbers of engineers that they need to bring on board, and looking at the number of engineers that are graduating from schools throughout the United States, and understanding that the brutal realization that we can hire every single engineer that's graduating from college and put them to work here in one state. So how are we going to compete with nationwide when there is so much demand for these types of engineering specialties, civil engineers, the geotechnical engineers in particular. The demand is so high. How do you compete? Because there aren't enough of them coming out of school, and so there is this kind of realization that there's some big challenges on the way. From our standpoint, on the geophysics side, I think we're a little less because I think we're actually seeing more people in the field who are coming on board, and we're seeing more people who are interested in coming in to work for us, which has been positive for us, because we appreciate that, because it's good to see that there are good people coming out of schools, and and there are places for them to go, not just here internally within California Department of Transportation, but there are environmental and engineering consulting firms that are picking them up as well. So there's a pretty good demand, and I don't have a great handle on what's happening in private, but I know on the public side, public service side, we're actually doing okay. We have enough people that we're able to hire as vacancies open up. So it's and we've been able to get some good candidates. So it's been a pretty positive aspect from our side.
What would be your advice to somebody thinking of getting into, well, surveying particularly, but civil engineering, I guess, is a wider topic, in terms of what types of things should they focus on in their education, what types of side things should they investigate and gain experience to see, I guess, whether or not they like it, and then to further themselves down the career path as they go.
Yeah. Well, there's always the recommendation that take a course in geotechnical engineering. So it's we have lots and lots of engineers that want to build bridges. We have fewer of them that want to design foundations. So those are the stuff that's in the dirt. The stuff that nobody ever sees, that is vitally important to actually keeping a structure upright. Those are some big challenges. So it's just basically as broad an educational base as they can get. And on the geophysics side, it's getting people to understand that in order to be a good geophysicist, you also need to be a good geologist. So you need to take as many geology courses as you can as well, particularly structural geology. You need to kind of understand, what is a syncline, what is an anticline, what might a fault look like on your geophysical data set, and so those are kind of things that are pretty important. It's not just being able to run surveys and code in Python, although the coding abilities are always valued, but being able to go out in the field and understand how what you're measuring ties into what is physically underground is vitally important.
That makes sense. And it seems like there's a pretty wide demand, really, for any type of physical engineering aspect, that you have your choice if you're of that bent and, say, 17 or 18. What, and I'm changing the topic a little bit. Um, as an internal service provider, do you actually deal with external contracts to private companies at all? Specking them out, working with them, managing that process. Do you really see much of that at all?
We see it only in terms of a support function. So we don't have any internal contracts ourselves that we manage, but there are other external contracts that are managed by other people that we provide input and we can provide recommendations to them in terms of evaluating scope of work, developing a good scope of work for a contract, and also evaluating the responses that are coming in. And so we haven't done it in a while, but we have participated in the past on evaluating NDT contractors for example, for ground penetrating radar surveys. We've been intimately involved with our folks on the maintenance side in terms of getting people on board that can provide that service and trying to find qualified providers for those services. But in terms of us doing it on ourselves, we don't have any service contracts of our own. But again, we have provided support in evaluating those services and making sure that for those people that are contracting for those services, that they're getting the kind of provider that they really need.
Have you noticed anything that you wish these guys understood better about the position of the way that the government has to either approach putting out those contracts? Do you think there's any kind of difference in the way that you're seeing the contracts being put out there, and something that you think you wish the private sector would understand better about being able to work with the government on a contract?
Mm-hmm. Most of the providers that we've seen that have come on board have usually been pretty good at understanding what the process is. So they've normally been pretty responsive. I know in the past we've had some situations where we've had some very good providers come on board and not understand that the state contracting process is a pretty detailed process. I mean, they're I almost likened it to it's like you're getting a proctology exam. I mean, we are looking at essentially every aspect of your business, and so when the scope of work comes in, we need to know not only just who your rates are, but who your subcontractors are, and you've got the resumes of your key personnel, but now we need the resumes of your subcontractors, to people that you're going to rely on to do your work, and that there's just a very detailed examination of the business process, so that in the end, if we're writing for example, if the state of California is writing a $20 million, $30 million contract, they're going to be very interested in understanding, is this person who is coming on board, or is this company that is coming on board to provide the service, will they be able to do it, within the, will they be able to meet the scope of work, and will they be able to meet schedule? And so that's kind of, if I'd say if there's any one thing that I would advise anybody from private who is thinking of contracting with the state, is understand that it's a detailed process, and it's a time-consuming process as well. And it's I wish there were ways that I could make it better, but I am outside of that process, so I can only advise. I can't
Happily, it sounds like outside of that process.
Yeah, it's like I don't really want to do it. It's tough. It's a tough job.
It is, and it's interesting to see. Having obviously worked with a lot of states and the federal government and the DOT or DOD. There's just some things that you have to understand about working with a government agency, about the way that they do business, and sometimes by law, they don't have any choice in the matter. It's A, B, C, D, and that's it. And it's interesting to see the frustrations when you really can sit and talk with some of those guys, that there is sometimes a disconnect in the communication, and hopefully that lessens as time goes on and makes it easier on everybody, so that the government gets the services that they need, and the contractors have a better process to keep happier customers.
Right. Because oftentimes the people who are developing the scope of work are ultimately the people that are not reviewing the contract. The people who have developed the scope of work might be the people that will ultimately be using the contract, but the people who are going to review and approve the contract are a different office entirely, and they have different objectives. They have different policies and procedures. They might have different, different procurement laws that they have to follow. And so,
Yep.
the great ideas that people who are actually going to be the users of it might have may not necessarily comply with whatever state or federal policies or federal laws, state or federal laws that we have that dictate how we contract for services. So there's always those situations that we have to be aware of.
And the dance continues on that side.
Oh yes.
I know we've covered a whole bunch of really kind of wide-ranging different topics. If you had a magic wand to fix different things in frustration of the survey world right now, any aspect of it, what would that wand look like, and what would it fix?
Oh, good grief. That's a tough question. I don't know if I have a good answer for it. Let's see,
And that's a fair answer.
what would I fix?
Technology,
Yeah.
problems. I know, and knowing you and understanding one of your favorite projects had you hanging on a line off the side of a bridge. Maybe
Yeah.
technology. Maybe you need more of those types of projects.
Yeah, those particular projects, those are ones that they're kind of the problem with those is accessibility, and that's not even a problem with the tools themselves. It's a problem of how do you get to the place where you need to make the measurement. And that's a big challenge. I think.
Do you think like drone technology? Actually, just interjecting a second. Autonomous drones to get into those hard to reach places. Dogs, aerial, whatever.
Yeah.
Do you think those will kind of end up being a solution to those types of problems?
That's actually I actually had a very good conversation yesterday with one of my other employees about this, and we had kind of come to the conclusion that the unmanned aerial surveying, or the UAVs, UAS type applications, are going to will have a good. They're going to be very successful in these niches for certain specific applications. And we've already seen some in terms of the aerial LiDAR, the aerial inspection of hard to access bridge structures, getting visual identification and visual images of certain portions of structures are going to be very good. And we've seen good success stories on those. And aerial LiDAR has been very successful for us in terms of mapping landslides, in terms of mapping structures, mapping progress on landslide remediation has been a big thing where we've had a lot of success internally, at least within the department. We have a group of people that go out and do this kind of application on a regular basis, and they're very, very effective. And there are some other things that it can have some good applications too. I mean, in terms of airborne electromagnetics are going to have some successes, but they're going to be pretty limited. It's going to be extremely difficult to run a UAV along a single lane of pavement with active traffic on the other side without causing multiple pileups from looky-loos watching this thing. As what is this? And, bam, rear ender. So they're really going to be. They're going to be great applications, but they're going to be limited to very specific areas where you can do it. And so anywhere where you can get close to the ground and you have lots of open space, UAVs I think are going to be very, very successful in mapping large areas. If they're relatively open and you have few obstructions, they can do a very good job. But we have lots and lots of projects where we have just limited areas where we can investigate, and it's just going to be very, very tough to get UAVs into those areas. So we're still going to have ground-based applications. But I know some of the stuff we've been seeing with the aerial infrared, it looks really, really promising. They're doing some really great work, and it's one of those situations where that's one of those tools that will lend itself very well to UAV type applications.
It was funny last year, the New York City Build Conference, which actually I think is going on this week. I stopped by, and there was a company that just did UAV IR. And it was fascinating because they were doing it inside of a city application. And I was sitting here, couldn't figure it out until I talked to the guy for a minute. But he would run over a building and do an IR scan and figure out where all the heat loss was. And as soon as he said that, I said, holy crap, that's a great idea.
Yeah.
Right? Lower your heating bills because you actually find out where the heck it's coming from. Really great idea.
Yeah, so in terms of UAVs, that's they're going to, as long as they're properly understood under what conditions they can be run, they're going to be extremely successful. And we're already seeing that. We're already seeing a lot of success with UAV applications. But I think like a lot of new technologies, I mean, you and I have both been in the industry long enough to have seen when the latest new thing comes along, how all of a sudden it's this huge thing. Everybody wants to apply it. Everybody wants to take it and put it on their project. And then we get reality set in, and then we have an understanding of what these things can and can't do. And then as the technology matures, we see these applications. I mean, I can think of 3 or 4 different types of geophysical tools, for example, that came online, and as soon as they did, they were oversold at first, and then as the people began using them and understanding what the limitations were, the technology matured, and you got this a better understanding of where and where they can't be applied, and then you get to that mature phase, and I think we'll see the same thing with UAVs.
Right. Well, great discussion. Last question: what's your favorite project?
Oh, gee, favorite projects. There've been a number of them. I would have to say there were 2 of them. I think the first one that I think was one of my favorites was the Toll Bridge retrofit program for state of California. This was in response to the Loma Prieta earthquake and the Northridge earthquake in the in late 1989, I believe 1991, 92, I believe. And so we essentially had to go and retrofit the foundations for all of our critical toll bridge structures, and we also were involved in actually replacing some of those structures as well.
Wow.
And so we were doing a lot of borehole geophysical logging work, and a lot of that was offshore. And that project was well underway when I first came on board to the department. That would have been like in 1994. And I remember my first week on the job, I was on a barge out in the middle of San Francisco Bay, getting into a man cage, holding on for dear life, getting winched up onto a barge to do borehole geophysical logging for projects. And so those things, you don't forget that. And that was one
hard to top.
Yeah, and we did a whole lot of work doing that, providing that information for seismic design. And I guess one of the best things about that was we learned how cost effective it was to do these tools, to the point where we were able to roll in some contract work that was being done and start doing it ourselves. And to the point where we were able to demonstrate some significant cost savings, such that our initial outlay of the equipment was paid for within a year by the amount of work that we were doing, by just combining the borehole geophysical logging functions such that we had it all under one roof and we could roll it in internally and make it work. And so that was a lot of fun. I mean, that was a number of years of doing that work, a lot of hard work, a few 24 plus hour jobs sitting on a barge waiting for a hole to get done. But those are part of the dues that you pay, when you're young and stupid, and you've got these. You think this is a great thing to do. It's not something that I would want to do too much anymore, but it's one of those things that you kind of remember. And in my second project, I really got to say it's had some fair amount of press, but I think just in terms of the success of it, which even surprised me, was the Oroville Dam response when the dam spillway failed, and we were tasked to come on board and do ground penetrating radar mapping of the remaining portion of the spillway. And that was just another one of those ones where you're just, you're working 16, 18-hour days collecting data and out on a project where, you may be called off on a moment's notice because, they have to reopen the spillway and you're just going to abandon your equipment and all that stuff's going to get walked away. But in terms of the quality of the data that came out, I mean, it surprised me. I mean, I didn't think it would be as good originally as it turned out to be, but the data looked so good. It really gave a big boost to the dam industry as well, dam safety in terms of moving forward and doing these kind of applications for dams throughout the state. So I think it was one of those big projects where you kind of demonstrate the efficacy of these tools and how they can be done in a rapid manner, and the amount and quality of the data that you can get out of it. I mean, there was just some beautiful images that we ended up getting out of that. So it's one of those ones that you just never forget. So
that's awesome.
Yeah.
It's certainly a very interesting OJT, I'm sure.
Mm-hmm. Yeah, those ones were very interesting indeed.
Well, anything that we haven't covered, sir?
No, this has been a great discussion. Yeah. So nothing more that I would have to add to it.
Excellent. Well, thank you again for being our first guest and interviewee on this. Mm-hmm. And it is always a pleasure to chat. We've certainly had some hilarious discussions over the years, and always very enlightening ones also.
No, so, great talking to you. Glad to participate. Hopefully this thing turns out well for you.
Yeah, and who knows? We're trying to have a rotating group of interviews with different hosts and different folks in different aspects of basically the survey world. So we'll see if it turns out and anyone shows up and likes what we're going to try and do. So always a pleasure, my friend. I think that's pretty much it. We want to thank our main sponsor, Contour, as always, and also, please look up SSI and our friend Nick Schaefer. Great folks who've just come on board as new sponsors for SurveyHub. So I guess that's all we have here. A pleasure, my friend. We will talk again soon, and thank you very much for being our first guest.
As always, thank you.
All right. Talk to you soon.
Okay, bye-bye.